Hi everyone. Welcome to our first content video on definitions of statistics, probability, and key terms. This material is a summary of what is in section 1.1 in your textbook. Let's start with statistics. What is it and why are we here? So statistics deals with 5 important things. We learn how to collect, organize, summarize, analyze, and draw conclusions from data. So statistics is all about how to appropriately handle data and use it to make predictions and draw conclusions. We can split statistics into 2 different tasks, 2 different major skills. The first is descriptive statistics, and it does what it sounds like. It describes things. Specifically, it describes sets of data. The second type is inferential statistics. We're going to make inferences based on data, like drawing conclusions, looking for relationships, testing the validity of statements somebody else has made. The first 3 skills, collecting, organizing, and summarizing, belong to descriptive statistics. We're not making predictions with our data or extending it beyond what we have in front of us. We're just collecting data and then organizing it in a way that is more understandable for others. Inferential statistics is the analysis and the inference, or the drawing conclusions. To connect descriptive to inferential statistics, we need to talk about probability. Probability is the measure of the likelihood or chance of an event occurring. You see them pretty regularly when you look in a weather app, trying to determine whether it's going to rain or not. They'll give you a percentage which represents the likelihood that it will rain during that hour. It is also a tool that is used to study randomness, and most importantly, in the context of statistics, it is used when making predictions. So as a statistician, we're going to look at sample data. We're going to make a statement about the population based on that sample data. And then we're going to use probability to make a statement about how likely our prediction is to accurately represent the population. We can also use probability to test the validity of statements others have made. Those predictions are the bulk of statistics. That's the super powerful stuff. And that's what we're going to cover in the last about 2/3 of the class. So we're going to get most of our descriptive statistics done during week 1 and a little bit during week 2. So that we can spend plenty of time on this big important statistics skill. We see probability represented in 3 ways. You've probably encountered probability as a percent. When probability is used in news and reporting, that's often how it's presented, because it is easy for people to conceptualize what a percentage is. However, in statistics, where we are calculating those probabilities, decimals and fractions are preferable. Decimals are going to come from any calculator calculations, and fractions are going to come from probability problems when we have information about samples. The upside to fractions in statistics is we don't need to reduce them. It is okay to leave your fraction unreduced, and that actually makes it easier to compare probabilities for different events when those fractions are left unreduced. We got a couple of key terms we want to get through. I'll try and do this quickly. First is population versus sample. The population is the whole group of interest, and the sample is a smaller subset of that group of interest. For example, if I, as a statistician, want to study the average height of all adults in the US, the population is every single adult in the US. However, for practical reasons, I can't actually go around and measure the height of every single adult in the US. So as a statistician, I would want to select a sample or a subset of adults in the US. It's important when we choose our sample that our samples are representative. That means the samples accurately reflect characteristics of the population it was drawn from. And to do that, we're going to use a randomness to help us, and we'll talk more about ways to randomly sample a group in a later video. When we pull data from populations and samples, we then want to summarize that data with values that describe characteristics of the group. A parameter is a summary value that's calculated based on data from the whole population, P with P. A statistic, on the other hand, is a value that's calculated based on sample data, S with S. When you're looking at symbols, it's usually easy to tell the difference which one's which. Parameters are almost always Greek letters, mu and sigma here, whereas statistics are almost always English letters, X with a bar over it, and S. What we're going to do is use statistics, values pulled from samples, to estimate the population parameters that we can't practically measure. So our last slide, we're going to talk more about variables throughout this week, but to get an intro, a variable in statistics is used to represent a characteristic or measurement for a population. So just like in other math classes, it's a placeholder for something we don't know yet, but we're interested in. We typically use capital English letters, so capital X, capital Y, to represent those variables. So we're going to see lots of capital X over the first few chapters, and then towards the end of the course, we'll start to see both X and Y as we look at bivariate or two-variable data. We can sort a variable into two types, numeric and categorical, and those kind of are what they sound like. A numeric variable is one that can take on number values, and categorical variables are variables that sort people or objects into categories. So examples of numerical variables are height in inches, or number of tickets sold to a new movie. Whereas categorical variables are things like blood type or hair color, things that can't be represented with numbers in a practical way. Okay, if you have any questions, let me know via email. Otherwise, I'll see you in our next video.